Hi everyone, in this video we'll be talking about heterogeneous catalyst, and this presentation is made by me, Angela, Klanta, Dylan, Ella, and Josh. Heterogeneous catalysis occurs when the catalyst is in a different phase to the reaction mixture. This is usually when the catalyst is in the solid phase, whereas the reactant is in aqueous state. Heterogeneous catalysis also often involves gaseous molecules reacting at the surface of a solid catalyst. The mechanism of the catalyst can be explained using the theory of adsorption, which is when the reactant is chemically bonded to the surface of the substance.
The Haber process is a reversible exothermic reaction where it involves the nitrogen and hydrogen gas to manufacture ammonia. The catalyst will be an iron powder in a solid form. This would be a heterogeneous catalyst as the reaction mixture are in gaseous form, but the iron is solid, so they have different phases. The surface of the iron, which is catalyst, will act as the place where a reaction occurs. The first thing to happen is diffusion to the surface. The bonds between the hydrogen and the bonds between the nitrogen will be broken, and the nitrogen and hydrogen gas will diffuse to the surface of the iron. Second will be adsorption, which means that the reactant molecules bond to the surface of the catalyst. Hydrogen and nitrogen diffuse with the surface of the iron, which allows them to attach and create a bond with it. The bonds between the iron catalyst and reactant molecules are stronger to weaken the covalent bonds between the nitrogen and hydrogen molecules so that the atoms can instead react with each other. Third will be the reaction, where the new bonds will continue to form. After that, desorption occurs where the bonds between ammonia and catalyst are broken. Although the bonds between the iron catalyst and the reactant molecules are strong, they are weak enough for when the new bonds are formed, the bonds can easily be broken, allowing the products to leave the surface. That is when the diffusion away from the surface occurs.
Following on what Klanta had discussed, I'll be talking about the heterogeneous catalyst used in the catalytic removal of oxides of nitrogen from the exhaust gases of car engines. Now, we need to know that the catalytic converters have a honeycomb structure, like this one, that contains small beads coated with the following heterogeneous catalysts: platinum, palladium, or rhodium, which are all in the solid state and in different phase with the reactants. As you can see here, the nitrogen oxides will then be converted into nitrogen gas. And then the carbon monoxide will be converted into carbon dioxide gas, which I will explain further after this. Moving on, the mode of actions of the catalyst is as follows: adsorption of the nitrogen oxides and carbon monoxides onto the catalyst surface. Next, the weakening of the covalent bonds within the nitrogen oxides and carbon monoxide. Next, formation of new bonds between the adjacent nitrogen atoms to form nitrogen gas molecules, and carbon monoxide and oxygen atoms to form carbon dioxide molecules. Lastly, desorption of nitrogen and carbon dioxide gas molecules from the surface of the catalyst, and this is usually known as diffusion. So that's all from me today. Thank you for listening, and I'll see you next time.